Right, here's our chapter one test review. First off, we're going to start with finding the absolute value. Remember, the absolute value is just the distance a number is away from zero. Okay, so if we think about it on the number line, here's zero, here's -7. How far away is -7 from zero? Well, it would be 7 units away, meaning the absolute value of -7 is +7. For number two, I got the absolute value of 6/7. Right, I got 0, there's 6/7. Right? I'm thinking how far is this distance? And again, right, absolute values are always positive, meaning this answer is 6/7. Right? For numbers 3 through 8, I'm either finding the sum or the difference. And it says to write fractions in simplest form. Okay, this is where we got to make sure we're paying attention and seeing, am I adding or am I subtracting? Okay, for the first one, I am adding. So I need to uh, see what is -5 plus -2. Right? We have a visual model that we could use, or you could use anything else, right? 5 negatives plus 2 negatives gives me 7 negatives. Could have also done this on the number line or something like that. For number 4, it says 10 minus -3. This is an opportunity to do karate math. We'll chop the subtraction sign into positive, and we'll chop the negative into a positive to make it +3. 10 plus +3, that's just going to result in 13. Number 5, I'm adding, so I don't have to do any karate math. What I do want to do, though, is turn this into an improper fraction. Okay, 2 times 4 is 8 plus 1 is 9, and this is negative 9/4 plus 1/8. I can't add yet because I don't have common denominators. The way I'm going to do that is multiply this by 2 and that by 2. -9 times 2 is -18/8 plus 1/8. In this situation, I got a negative and a positive. Those two are going against each other. They're working the opposite way on a number line, meaning I'm going to subtract 18 minus 1 and get 17. This is going to result in 17/8, and it's negative. A simplified version of this, well, 8 can go into 17 two times, and there'd be 1/8 left over. So we'd say -2 and 1/8. Number 6, I'm adding, so I don't have to worry about doing any karate math. I have a negative and a positive, so those two are working against each other, right? I have to borrow from my neighbor. 11 minus 8 is 3. 2 minus 2 is 0. My greater value is negative, so that's the one I'm going to go with, meaning this is -0.3. For number 7, I've got -2 and 1/6 minus a 6. Right, this time I do have the opportunity to do karate math. We're going to do a chop slash. Now I'm adding -1/6. 2 and a 6, uh, if I change this into an improper fraction, is going to end up being 6 times 2, which is 12, plus 1 is 13. Over 6, keep it negative, plus -1/6. This time I've got two negatives, those are working together. 13 plus 1 is 14. Keep it negative. There are 2 6s that can fit into 14 with 2 left over. And then this simplifies to -2 and 1/3. Number 8, I have an opportunity for another set of karate math. We're going to chop chop, giving me -2.36 plus 5.7. I've got two numbers that I have opposite signs. They're working against each other, meaning I need to subtract. Right? If I've got nothing above the 6, I need to add a placeholder 0 in, which then lets me do this. 10 minus 6 is 4. 6 minus 3 is 3. 5 minus 2 is 3. I get 3.34. Check my sign. Well, my bigger value was positive, so this stays positive. 3.34. Right? Number 9 and 10 asks us to find the distance between two numbers on the number line, right? Instead of looking at value, we're seeing how far away are two numbers from each other. Okay, I'm going to put in my 0, and I'm going to think -3/5 Well, negative numbers are to the left of 0, so we'll put negative 3/5 right here. Okay, 2 and a fifth is positive. It'll be to the right of 0, and it's a lot further from it since I have a whole number out front of 2. And now I'm trying to figure out what is this distance right there. Well, I have a couple things I know. I know from negative 3/5 to 0, I go 3/5, or the absolute value of it is 3/5. And then from 0 to 2 and a fifth, that distance is 2 and 1/5. Meaning to get the total distance across, I'm going to take 2 and a fifth, and I'm going to add 3 and 3/5. You may have seen it written: take the greatest number and subtract the other number, which in this case also results in us adding them together. Either way you think about it, we'll add these two together. 2 and a fifth can be rewritten as 11/5 plus 3/5 is 14/5, right? 14/5 can be simplified down to 2 and 4/5. That would be my distance. Okay, for number 10, both my numbers are negative. I have negative 2.3, which is closer to 0, and then negative 6.1, which is further away. And I'm asked, what is this distance right here? Now we kind of have to think the opposite, right? I know from here to here is 6.1 units away, and I know that this distance is 2.3 units away, meaning how much is left to go before I hit 6.1? Well, in this case, what we're going to end up doing is we're going to take 6.1 minus 2.3. And again, if you learned it the other way, right, take your greater number and subtract your smaller number. Again, we see when I chop, I've got one positive and one negative, which makes sense, correct? Because I've already kind of used up some of it and I just want this portion. So we're going to take our full 6.1 and subtract what we already have. This becomes that. 11 minus 3 is 8. 5 minus 2 is 3. We get a total distance of 3.8. Number 11 says, consider the expression a plus b, where b is a negative number and a is less than b. Is the sum positive or negative? All right, a couple of big things to note. Okay, first of all, b is a negative number. That's really important. What else is important is this: a has to be smaller than b, and I'm looking at the sum of these two numbers. Okay, so I have some value of a, some value of b, and I'm wondering, is this going to be positive or negative? Okay, well, what we can do is we can kind of test this to see, right? Let's start with the smallest negative number we have for integer. Say, hey, what about -1? Fill it in for b, right? B is a negative number. That's satisfied. Something smaller than -1, right? Which kind of talks about this part, would be something to the left of it, right? Well, what's the next number left of -1? -2. Okay. -2 plus -1 is -3. And what we can see here is no matter what I put in for b, right, I'm just going to either get a bigger negative number. Okay, let's make b -3. Well, a has to be smaller, -5 smaller. -5 plus -3 is, okay. When it asks, how do I know? Okay, my answer is going to be negative. I know this because since b is negative and a is less than b, a has to be negative, and the sum of two negative numbers is always negative. Right? Just by kind of looking at that, no matter what B is, A has to be smaller, so A has to be negative, and I will always end up with a negative answer. All right, moving to the back side here. Number 12 says the table shows the 4 accounts or account transactions. Find the account balance after the transactions when the account started with a balance of 50. So let's think about this, right? Deposits mean adding, I'm putting money in. Withdrawals mean taking away, something like that. Okay, if I add together my deposits, right, 50 plus 25, that is $75. And what I'm noticing is, oh wait, look, I am also have a withdrawal for 75. This means I put in 75. This means I took out 75. We have a set of zero pairs going on, meaning I can actually cancel these two, leaving me with the only thing left of having a withdrawal of negative 10. 50 plus negative 10, 50 positives, 10 negatives. The result of this is going to be $40. Okay, just to show you, right, if you went through and you added each of these, 50 plus 25 is 75. 75 plus 50 is 125. But then we have a withdrawal, so I'm going to subtract 75 from that and get 50. And then I'm going to bring this up here. 50 minus 10 again is 40. So even if you didn't recognize that right away and you went through with everything, we still get an answer of a balance of $40. All right, for number 13, it says find negative 3/4 plus negative 3.5 plus 2.25. Okay, a couple different ways we can do this. I'll show kind of both of them. Essentially, what we have to be thinking about is, am I wanting to use all fractions or am I wanting to use all decimals? And I'm going to do it both ways. Okay, for the fraction side of things, the only thing we need to change here is 2.25. Okay, and if what I like to always do is think about money, right? How much is 25 cents? Well, it's 1/4. 1/4 is also the same as 1/4. So if I were to rewrite this, I would say negative 3/4 plus negative 3.5 plus 2 and 1/4, or 2 and 1/4. Now from here, my next step would be, right, I want to make sure that I can add these, so I'm going to make all these improper. Negative 3/4 is fine to stay. Negative 3.5, well, 2 times 3 is 6, plus 1 is 7. Okay, don't drop your negative out, make sure that stays. 4 times 2 is 8, plus 1 is 9 over 4. Okay. Next step, right? Do I have common denominators? I don't, but I only have to change one. I have to change the middle one. How do I change it? Well, 2 times 2 is 4. And whatever we do with the denominator, we have to keep the scale factor. So we'll multiply by 2 up top. Okay, this is going to result in negative 3/4 plus negative 14 over 4 plus 9 over 4. Okay, these two are both negative. We're going to add them together. Negative 3 plus negative 14 is negative 17 over 4. And we'll continue to add in our positive 9/4. Negative 17, positive 9, those two are working opposite of each other, right? If we do 17 minus 9, we end up with 8. So my final answer is going to be, this is 8/4. Which one is it, positive or negative? Well, this has the greater absolute value, so we're going to say that this is negative. How many fourths can go into 8? There can be 2 of them, meaning my answer is negative 2. All right. What happens if we want to do it the other way? What happens if we convert all of these to decimals? Okay. Well, 3/4 or 3/4, right? How much money is that? That's 75 cents. And I'm going to put a negative on there. Then we've got negative 3.5. If I have half of a dollar, that means I've got 50 cents. So we're going to add negative 3.50 and then finally add 2.25. Okay, these two are both negative, so we're going to add them together. They work together. 3.50 plus 0.75 gives us 5, 12, and 4. So this is going to be negative 4.25 plus positive 2.25. Those are in a power struggle. They don't like each other. 4.25 is the greater value. We're going to put that on top. 5 minus 5, 0. 2 minus 2, 0. 4 minus 2 is 2. My greater absolute value is here, meaning my answer is not 3, is negative 2. Either way you do it, fractions or decimals, we get the same answer. All right, 2 left to go. Number 14 says a water softener salt contains 10 pounds of salt. It typically uses 0.75 pounds during the morning and 0.5 pounds each evening. How many days until the salt runs out? Okay, so let's think about this. In the morning, I use 0.75, and in the evening, it uses 0.5 or 0.50. Okay, if I wanted to know how much does it use in one day, I'm going to add our morning and our evening values together. Okay, 0.75 plus 0.50 gives us 5. That's 12, and I get 1.25. Meaning, every single day, I have 1.25 pounds used. Okay, I start with 10 pounds of salt. I want to know how many times can I use this before I run out. Okay, so again, a couple different ways we could do this. I like to make a chart. Okay, we'll say this is the day, and this is the number of pounds that have been used. On day 1, I use 1.25. On day 2, right, I use another 1.25, meaning my total used jumps up to 2.50. Day 3, we're going to add 1.25 again, which gives me 3.75. And finally, on day 4, we add 1.25, and I get 2.5. Now, in my head, I can see a pattern here, right? It took me 4 days to use 5 pounds. And if I have a total of 10 pounds, right, well, that's going to be another 4 days. Okay, if you can recognize that and say the answer is 8, awesome. You need to keep going, that's okay. Okay, see if we can't fit this in here. All right, I'm going to add 1.25 and I get 6.25. Add another and I get 7.5. Add another. Let's erase this a little bit. Right, on day 7, add 1.25 and I'm at 8.75. And finally on day 8, if I add another 1.25, I get to 10. Okay, what does this mean? How many days until the salt runs out? Well, on day number 8, I use all 10 pounds. So we would say this is 8 days. All right. Number 15 says a drone is 300 feet above the ground. After 1 minute, it is 240 feet above the ground. Okay, so here's my little picture. Here's my ground. This would be 0, right? We would say the ground is our 0 point. It's the drone, right? If we draw our little drone here, some sort of box on it. Okay, it started at 300 feet, and then after 1 minute, it went down to 240 feet. Find the change in height of the drone. Basically, how much did it go down? Well, if I start at 300 and I go to 240, we can find that out by subtracting the 2, meaning my change in height ends up being 60 feet. Now, right, we have to think about it. Since I'm thinking about height, right, that has to have a direction on it. When I put a negative on this means This is going down 60. I started at 300, I went down to 240. This change is negative 60 feet. Part B says this, if it continues to ascend at this rate, how long does the entire descent last? All right, so we know from here to here, it took 1 minute, and I went down 60. So that means after another minute, I'm going to go down another 60 feet. Well, 240 minus 240 minus 60 is 180. Another minute down, we get 120. Another minute down, and we're at 60. And finally, the last minute here would be back down to 0. Okay, so the entire descent down would be how many times did I jump 60 feet down? Well, I did 1, 2, 3, 4, 5 different times. Right? We also could get that by thinking, okay, if I go down 60 feet per minute and I start at 300 feet, how many minutes is that going to be? Well, 60 doesn't go in there, doesn't go in there, but it goes in there 5 times evenly, meaning that's another way we could say, hey, this whole descent takes us 5 minutes. All right, there's our chapter 1 test review.